In this video, I'm going to talk about two different types of mathematical spiral. First of all, we have this blue one, the Archimedean spiral, named after the ancient Greek mathematician Archimedes. And I'm also going to talk to you about this red one, the golden spiral, which is intimately connected with both the Fibonacci sequence in maths and with the golden ratio, the number which is roughly 1.618. So I'm going to very quickly talk about the differences between the two, and then I'm going to show you how you can draw them, both freehand and using a computer. So let's start off by looking at the Archimedean spiral. This is the sort of spiral you end up with if you have a long roll of carpet and you roll it round and round around itself and then look at it edge on. It will look something like this. It's also the sort of spiral you end up with if you have a long piece of rope and you just coil it round itself and round itself just like this. So as we start at a center point in the middle here, and then we move round and round it, but as we do so, we move further and further away from that central point, but at a steady rate. And this is one of the most noticeable features of an Archimedean spiral, because the distance between successive coils is the same. Let's also have a look at it on this program. I'm just going to spin it round and rotate it. Isn't that a fantastic optical illusion? It looks as if you're sort of coming away from the screen. And if I rotate it in the other direction, it's a bit of an optical illusion. It appears that you're sinking into the screen. So that's a nice, fun couple of things about the Archimedean spiral. Now let's move on to a look at the golden spiral. Again, we start at a central point, we move around it, and as we move around it, we move away from it. But this time we do so at a rate that keeps increasing. And it's easy to see this because if you look, the distance between successive coils keeps increasing and getting larger and larger. This is quite different from the Archimedean spiral, where the distance between successive coils stayed the same. And look what happens if I zoom in to the spiral. It's kind of like an optical illusion. It appears that the spiral is just rotating, but actually what we're doing is zooming in and zooming out here. Now, this self-similarity property is very different from the Archimedean spiral, because it would be easy to see if we were zooming in or zooming out of the Archimedean spiral, because the distance between successive coils would keep increasing or decreasing. So let's now see a few different ways in which you can create your own beautiful Archimedean spirals. Firstly, by hand, you'll need some squared paper, then draw a nice long pencil line, and then make some equally spaced marks along it, perhaps every 2 centimeters or whatever you like. The next step is to get a pair of compasses and to draw a small semicircle like I've done here. I've actually done this to save time on the computer, but you can just do it with a pair of compasses. So the next step is that you need a slightly bigger semicircle, and I'm just going to place this under here like this, connecting the next 2 marks. Then we're going to get another semicircle and make this one a little bit bigger so it connects the next 2 marks. Then here's our next semicircle, and we're going to build up our Archimedean spiral with a sequence of semicircles. Now I should point out that what I'm drawing here is not actually a true Archimedean spiral, because with a genuine Archimedean spiral, the curvature increases continuously. Whereas with this, it's been made from a sequence of semicircles, so the curvature is the same, and then it jumps as we move to the next semicircle, and then it jumps again. But it's a really good approximation to an Archimedean spiral. So how else can we do it? Well, here's one I've made on Microsoft PowerPoint, and it looks really nice now because I've got the computer program to draw the semicircles. You might be able to see the little gaps I've intentionally left, so you can see how it's built up from semicircles, and it's even clearer this one because I've coloured in each of the different semicircles in a different colour. So how do we do that? Well, very simply, you go to Insert, Shapes, and then I'm going to choose this one here, which is an arc under Basic Shapes. I'm going to draw a nice arc here, and by moving this yellow button, I can have as much or as little as a circle as I want. I just want exactly a semicircle, which looks like that. So now I'm going to copy and paste. I'm going to copy and paste. There we go. And now I can make this one bigger, flip it upside down and glue it onto the first one, and so on. And so you can build up your Archimedean spiral that way. A third way you can do it is by getting a graph sketching program such as this one, GeoGebra. You can also use Desmos. Both of them are free, and very simply all you need to do is to type in R equals a theta. Now the procedure to get the theta is going to be a little bit different depending on which graph sketching program you're using, but the parameter A can be varied. I can make it bigger or smaller, and that's going to change. It's going to reduce or increase the distance between successive coils of the spiral. So there we have three different ways for you to create your own beautiful Archimedean spirals. So to finish off, I'm now going to show you how to draw your very own beautiful golden spiral. You'll need squared paper, and we're going to start off by drawing a little square. Now we have another square next to it. Then I'm going to spiral around the original square, drawing more and more squares. We have a 2 by 2 square. Then I'm going to come to the top and draw this 3 by 3 square. Then at the side, how big is the next square going to be? I guess it's going to be 5 by 5. And then underneath that, it's going to be how big? What is it going to be, like 8 by 8? And then the next one is going to have to be quite a big square. What is it, 13 by 13, something like this? Hang on a minute, I recognize these numbers. These are just the Fibonacci numbers. So let's have a look at the edge length of these squares. It was 1, then it was 1, and then the next one was, well, it's what you get if you add these two numbers. It was 2, and the side of the next square was 1 plus 2, which is 3. The side of the next square was 2 plus 3, which is 5, and then 3 plus 5 is 8, and then 8 plus 5 is 13, and so on. This is what we call a Fibonacci sequence. So we can start to see how this golden spiral is related to the Fibonacci sequence from mathematics. So now let's go to a different color. I'm going to make the pen a bit thicker because now we're going to start to draw our spiral. In each of these squares, I'm going to draw a quarter circle. For the Archimedean spiral, it's made up of semicircles, but this one is made up of quarter circles. And inside each square, I'm just going to draw a quarter of a circle. It's getting a little bit harder because I'm doing this freehand, but obviously you can use a pair of compasses and make a really, really good one here. This is actually not a true golden spiral, it's an approximation because it's made up of quarter circles rather than the curvature changing continuously. But the more and more bits you put on, the closer and closer and more closely it resembles a genuine golden spiral. So one last comment before you go away and create your own spirals. The thing that inspired this was at the weekend that's just passed. I spent a lovely few days on Brighton beachfront, and here I am at a very curious sculpture made of rusted steel pillars, and they seem to be in a really funny arrangement. It wasn't until later in the afternoon that I got up really high that you could see that these steel pillars were actually arranged in this beautiful pattern, which I now know is a Fibonacci spiral, which is a very close approximation to a golden spiral. So there we have it, Archimedean spirals and golden spirals.